Welcome to Engage Math, Lesson 28, Problem 4. And I'm assuming you already read the problem, so we're going to jump right in and look at Part A. And it says, in terms of x, how long is one of the sides perpendicular to the house? So we know perpendicular means that it forms right angles. So these two sides are going to have to be congruent. I'm going to make these sides green. And I want to really emphasize that the side that was given is going to be this side. It's not really given as a number, but it's the variable x, because they told us to let x represent the length of the side parallel to the house. So the red side is x, and the green sides, we're going to figure out how to write that. So if we have 200 feet of fencing, what we know is we've already used x amount. This side right here that I'm going to kind of highlight in blue, that does not need fencing because the house is going to be used to kind of secure that side of the pen. But what we do need is we do need to fill in or kind of put fencing along these two sides. So what we're going to say is we have 200 feet of fencing, but we've already used X amount for this side, the red side. So we are going to subtract that off, and then we're going to divide by 2 because we have two places, two sides of the pen that need the fencing, the green. So what we can do is out of the 200 yards of fencing, 200 feet of fencing, we've already used X amount for the red, and then we're going to divide the rest by 2 so that we get each one of the green sides. So I'm going to do this sharing is caring, where if we have two terms in the numerator and one number or one variable in the denominator, they both have to get divided by that 2. So it's really 200 over 2 minus x over 2. And I'm going to just simplify that to 100 minus x over 2. So that represents either one of the green sides. So now we're looking for an area formula function. So I'm going to say a of x. We know how to find the area of rectangles because now it's going to be the x times one of the green sides, which we know is 100 minus x over 2. So now we can maximize the area. So I'm going to zoom in a little bit just to make sure you can see this all really clearly. And what we know is that to maximize, we're looking for the x coordinate of the vertex of this quadratic function. This would be the x value that would maximize our area. So I'm going to rewrite that area formula, a of x equals, and I'm going to distribute that x. So I'm going to get 100x minus x squared over 2. And I'm going to rewrite that in standard form. So I'm going to rewrite it as a negative 1 over 2 x squared plus 100x. The reason I'm rewriting it in this form is I think it will help you to see what a and b are in order to find negative b over 2a. So now negative b is negative 100 over twice negative 1/2, because that's over 2a. And so we have negative 100 over 2 times negative 1/2 is going to be a negative 1. So we're going to get that the x coordinate of the vertex is 100. And what that really means is this red side right here is 100. And then to find the green sides, what we have to do, I'm going to actually put that 100 already over here, and it's in terms of feet. And then to find the green sides, we're going to take that value of 100 and substitute it in to what we know is the other two sides. So we're going to say 100. Let's write that somewhere else so you don't think it's a fraction. So what we're going to do is we're going to say, to get the other dimension, we're going to say 100 minus, and it just happens to be 100 again, over 2. I'm just going to make sure you see this is coming from there. Okay. So we now have 100 minus 50, which is equal to 50. So the other dimension is 50 feet. And it all makes sense because if the red side is 100, the other two sides would each be 50. That gives you a total of 200 for the perimeter of the three sides. We don't need to worry again about the house. I'm going to zoom back in and now show you that the maximum area is going to be the 50 times the 100. So we know that that's going to be a 5 with 3 zeros, or 5,000. And because it's area, we're going to use the square, so it's 5,000 square feet. Great job, and we'll see you again next time at Engage Math.